Hey, Byron speaking. Have you been in a situation like me? That means you have to upload lots of videos to YouTube, yet it's unreliable, your bandwidth is low, and you're never really sure if that will actually work? I mean, sure, I'm dramatizing here, but still, I've had too many aborted uploads, and that just shouldn't be. The good news is that the Google APIs generally support resumable uploads for lots of resources, if not for all of the resources out there, which is great. However, if you use a browser window to do your uploads, you are possibly out of luck, you know? Do you trust it? I mean, sometimes you want to upgrade the browser, but you're doing an upload, so you can't do it. The latest security update is not for you, you have to wait. Same with the operating system. You need to reboot, but you can't because you're uploading. All this shouldn't be an issue. All this should just be working because you should be able to resume these uploads. And right now, it doesn't seem there is software that does that reliably. And I'm saying reliably. You need to trust it. It needs to be just working, and that's it. If it's not working, it must be something like hell breaks loose on earth for it not to work. Something like that doesn't yet exist. So I think it's the best way to program it yourself. Why not? There are bindings that allow you to talk to Google services for all the major programming languages. You name it: Java, JavaScript, Go, C++, whatever you like. I would probably have written this in Go, but on the other hand, I don't like Go so much, even though I see the benefits. I prefer Rust now. But for Rust, there's nothing like it. So I guess if you want to have a super resilient, fancy, great, and reliable YouTube uploader, you will first have to do Google API bindings for Rust.
The original motivation for the entire project was to have a YouTube uploader which is resilient and to errors and will just work. And while researching, you will realize that the first thing you need is authorization. Without authorization, nothing works, so that should be done first. OAuth 2 is the authentication style that is currently supported by many big players in the internet. And if you look at it, or try to find it for Rust, you will see that there are libraries already that do that. I think at least one that I found, but it seems to be quite specific to one particular case that didn't seem to work for me. So I realized that I might have to implement my own. What I was looking at and into was the device flow, because that was kind of easy to do and it requires no browser in the middle to do things. And there we are. Yup, OAuth 2. Yup stands for YouTube Uploader, and that's kind of the heritage of the entire OAuth 2 library. And so far I was not willing to rename it to something less specific, just because I'm not sure if I will ever support the entire OAuth 2 protocol, which is currently involving 4 different authentication flows. Right now, it only supports one, which is basically that, so that you get a code that you can enter at this particular URL, and then the authentication will be granted or will be not granted. That's pretty cool. And with that in Tau, it's really easy actually it's in theory possible to actually do something with YouTube and possibly other APIs. But even though I was going to impose a lot of work onto myself that might not technically be necessary, because I could just use one of the existing API implementations, it's at least advisable to look at them to learn from the best, right? Because it's probably a complex undertaking, and ideally you don't make the same mistakes twice, or at least, start off at a very different level. So the Go implementation here, as you can see, says YouTubeGAN.go. This should give you a hint at something, but initially I didn't even realize that all this code here that looks so pretty darn neat is fully generated. No human being has ever written a single line here, and the reason for this is actually quite clear. It's such a massive undertaking to implement something like the YouTube API. I mean, look at that. It is 12,000 lines of code nearly just to get that, and lots of repetition here. It's basically always the same, but with different functions, methods, data structures. It's quite crazy. And all this is based on this JSON file. That is the root of all the information. So if you have this JSON file, you're able to basically implement anything related to the YouTube API, because it should contain all the information that you need to do just that. So it seemed there's no other way but to use that, or to artificially restrict myself to just some YouTube features that I want to implement by hand. But that didn't seem right. Didn't seem right at all. And the benefits of having a generator kind of outweigh the extra cost, because this will then open up 75 Google APIs to your service, or to service you. Within this huge amount of pre-generated APIs, you will find the Google API Go generator. So what this is just a Go program that generates a bunch of strings that it then writes to the respective file, and that's it, really. Nothing special. Also, custom Go program to serve as or act as generator. So they don't use an existing template engine, for instance, to do that job. When you look at the generator's code, like here, generate code, you will quickly realize that the way it's done is kind of cumbersome, because it always deals with plain strings that it assembles in some way or another. Maybe sometimes with substitution, sometimes without, and this PN probably just prints it to the respective output. However, doing this in code is, I think, more difficult than having a generator that supports some sort of template mode, which allows you to have certain characters printed in text, whereas there are other places where you substitute the result of some code execution into the template. So doing this in an actual program to me wasn't an option. I wanted to use a generator and reap the benefits. Basically, the generated code that I could then do could be more complex without being too hard to understand, at least on the generator side. But which template engine should I use? I've had no prior experience with any of these, so I had no idea what to watch out for, basically. Fortunately, this page really came to my help. Thanks, Roland, for doing all the work in 2013. So it's not the most recent one, but better than nothing. And it definitely helped me to understand how template engines work and what they should support. He even mentioned some benchmarks here. And even though those didn't affect my decision, it's quite interesting to see how slow these engines can be. I really hope that I would pick a one that is actually fast, because after all, it's your turnaround times that are at stake here. However, quite a while ago, I've read a very, very interesting book, basically, on ZeroMQ. So Mr. Hinchins here, he was the one who wrote it and is a kind of a genius, I think. However, many years ago, his company has written GSL, which is also a code generator. It's actually a code generator. It claims to be a code generator, whereas everything else is claiming to be a template engine. In the end of the day, it's the same thing, but GSL really has some unique features. Unfortunately, even though I wanted to use it, I really tried, it turned out to be too unstable. But I will show you there was a critical bug in there, basically, that made it crash whatever you would do, which is also showing something about the project, I think, so I backed off. But I will show you how this looked like anyway, because I was testing quite a few options. The first contender for a code generator or template engine was GSL. I've been wanting to use it for quite a while now, and now is the time, I thought. So I jumped quite a few hoops to make that work. First of all, I have built this tool. It's a C program that, building it was relatively simple and straightforward, no issues there. But unfortunately, it only supports XML as input, and I have JSON files. So what I had to do is to search a lot of different programs that were able to convert these JSON files into valid XML. And I think I even modified one of the tools I found in order to actually make it work. Yeah, here that's the custom tool that I have crafted. So a lot of work has been spent already, and just to find out basically that when you actually try to use it, it will crash. And that's the default, that was just a test basically that I took directly from the web page. However, there was no way to get this to work. It would always crash. And this bug has been fixed a week later or something, and I haven't moved on from that point anyway. And I'm really, really happy about that, because I think GSL would have been troublesome at the end, considering the demands that I had. Pyrotemp is the tool written by the guy who has made this awesome and totally informative web page about template engines. And I thought, okay, if Pyrotemp is the digest of everything he learned from his research, and if that is everything he wants to be happy, then this must be something I can be happy with as well. That was the idea, and here it is. That's the first version of the dependency generator that generates makefile dependencies, a really, really simple program. And as you can see, there are two issues with that. First of all, it's relatively verbose for a template engine. I mean, there are nicer ways to do this. And unfortunately, because it's such an underdog, there's no syntax highlighting. And this makes it really, really hard to do anything really. Also, it's very limited to what it can do. So if you want to manipulate data or something, or write Python programs that deal with the input data, well, you have lost then, because that's really difficult and no fun at all. In any way, it worked. That was something, but I wasn't convinced. I couldn't really imagine to write an entire Rust API in that syntax and without any highlighting. So that was kind of conclusive. I couldn't use that one. The first in line after Pyrotemp, basically the one that Roland considered one of the best, was mako. And mako, honestly, was kind of my savior. Look at that. That's the Pyro version, and that's the same one written in mako. Quite a big difference. First of all, syntax highlighting. Even though it's quite primitive, it already helps to see what's generator code and what will end up verbosely in the file that you are currently dealing with. Quite amazing, and it makes such a big difference, honestly. Besides that, in mako you have blocks that can be pure Python and blocks that basically will be substituted, but within them you can also use pure Python. Basically you have the unlimited Python power while having a template engine, which is absolutely awesome. As you can see, I have just integrated, or I'm using virtualenv to get everything I need on demand, so this will work on Travis as well, and I don't have to basically copy all the code of mako and make it work with all the dependencies. No. But what I do is keep my own mako render file around, because this wants to be adjusted in order to support what I needed to support, basically better data input and cascaded JSON files. If you run this, it looks pretty much like that. You just run Python from the virtual environment, and then with that you run mako render and provide it with some information about what to do. That's it, and that should be the generator I use for the entire project, and I'm so happy that I chose this one, honestly. No regret there at all. My highest recommendations. The complexity of this project is very high, and even though we now know how to generate the code, there's so much more to consider. I mean, we need to get JSON files from the Google Discovery API that describes the API that we want to build. But if this JSON file changes, we want to rebuild the API, the generated code, right? The one is dependent on the other. We don't want to incur any extra work because that will be turnaround times. If you have to rebuild everything all the time, then, well, developing this will be quite a pain. But for this purpose, make has been invented, right? The make file here is the main one that is manually written, and that kind of serves as a hub for automatically generated make files for different kinds of programs that we want. For instance, there's one make file that keeps dependencies for API dependencies, and another one for the CLI program. And the one depends on the other even. So without make, we would have no chance to organize this and to run the tools easily without having to care about all the nitty-gritty details. It will generate something like this, which is a, well, massive, a makefile that you couldn't write manually and that you wouldn't want to write manually, because as you can see, it's, well, hard to read. But that's not what you read usually, because it's all based on the dependencies.mako file, which will generate that one for us. See, that's 180 lines that translate into no less than, give me a moment, 3,000 lines. I mean, that's pretty awesome, because here, this is just like the build plan for a file that otherwise wouldn't actually exist, because you can't just write and maintain such a thing manually. But that's why we are in the code generator business anyway, right? Make is at the core basically of everything, and it takes care of executing all the tools with the right command line arguments that we need to finally do something as simple as that. For instance, if I wanted to build the maps engine here, that's how I do it. If I wanted to build the CLI program for the maps engine, which right now is in, well, early alpha state, I would just do it like that. It's self-documenting, and without it, I couldn't do the job, that's for sure. It's hard to believe that initially I was even considering writing this by hand. Let's have a look at what we get. For instance, this is the Maps engine. I think this is what you want to use if you want to interact with Google Maps. And that file now has no less than 23,000 lines of code, but it includes all the documentation that you ever want to have. And yeah, let's dive into something that I find quite interesting. For instance, first of all, 23,000 lines, they correspond to 150 lines of this code. Yes, you see right. That's the mako code that effectively generates or expands to 23,000 lines of code. There are even bigger APIs that go up to 45,000 lines of code. And, well, lines of code is probably not the right term here, because it's just lines that we are seeing here, not lines of code in terms of a slug count. Anyway, as you can see, this is something you can even understand. And if you want to dive in, you can just follow up these method calls, because even mako is split up into its individual modules, into individual functions, in order to basically split this huge problem into many, many small problems that are much more manageable. Something I would have never imagined is the complexity of the types that are described by these JSON files. For instance, the GeoJSON geometry here is just that. It's a variant that has multiple different kind of values, which translates perfectly, absolutely perfectly, to a Rust enumeration. And if we dive in here, for instance, into the GeoJSON multi-polygon, you see that even the individual fields are highly complex types. We have a triple vector here that effectively contains these JSON positions, which are, let's see what they are, again, a vector of 64-bit positions. Amazing. And all this is defined here. And this is something that is generated, or this kind of type is resolved by this single function here, toRustType, which takes a lot of input, to be honest, but it needs all that data in order to figure out the right type and to recurse into this in order to resolve it properly. It's absolutely fantastic. As you can see, data structures are at the core of what the code generator actually does, because data you send to the server is usually represented by a custom structure, and data you receive is also represented by such a structure. And the serialization and deserialization part is at the core of the entire operation. Without JSON encoding and decoding, nothing would work. And this kind of shows already the difficulties that you can face, because some identifiers are not valid within Rust code, even though they're perfectly fine within a JSON structure that has no such restrictions on certain names. With the previous, or with the standard Rust C serialized JSON encoder and decoder, unfortunately you cannot rename fields. So serde came along to help, and actually without it, this entire project would have been doomed. I'm really, really happy to have it. That's the GitHub page. Eric is one of the main authors. He is the main author and did great work, because all the features that you need are actually supported. And basically, that's the main token here, or that's the main idea here. In the moment, we cannot represent or we don't want to represent the field name that is used in JSON. We can just rename it. Sometimes these matched up, then there will not be a rename field here. Otherwise, we will just rename it accordingly. That's pretty nice and extendable. Documentation has been a first-class citizen from day one. So here you see the index of all the API documentation pages for all the currently supported APIs. And if you have a look at the YouTube one, you see where this leads to. It's, well, a completely formatted documentation page based on Markdown, which is obviously all generated, all cross-linked and made to be telling you what you want to know. Oh, you want to upload something? Well, look at these functions they supported. Oh, here, download. You can download captions. Did you know that? That's exactly the information that is not directly visible usually, because you have to mine it. Mining in the sense of find all functions that support download and put them somewhere. But still, it's really useful to have, and that's the kind of documentation that I consider useful, and maybe I'm missing a lot of things that will be added later as well. Another cool feature is the ability to embed code here, which serves as an example. But it's not just there as plain text that looks like code. No, it is actual code that is tested when running the unit test, which is great because that way we know that this will actually work. If you put this into your own program, it will work the same way, provided you use the right Rust compiler, obviously, because we are still in kind of alpha, beta, pre-release mode here. That said, the documentation can be complex, and there's lots of structures usually that are involved in that. But usually with the traits here that are assigned, you can more easily basically find your way by drilling down, because the calls is in the end what will get executed and what will be done to the server. So if you want to rate a video, you would be interested in the video rate call, and here you can see how it's done once again. Pretty neat. That's a doc test, by the way, so that definitely works when executed, even though lots of additional information here is omitted just for brevity.
Now that the APIs are there, we can be happy, but so far there is no user uploader yet. There's nothing we can do with that system unless we try to write our own command line interface, which of course you could do manually just to get the uploader going, but where's the fun in that? I mean, honestly, where's the fun in that? Because it's kind of mechanical. There's not too much to it. Besides that, then you only have it for YouTube. What about Drive? Wouldn't it be cool if you have resumable uploads for Drive as well? Or for Gmail? You name it, it doesn't matter. It should just be there, and I think the only real way to do this, to test the system and to have something that you can use in your everyday's work, is if there is a generated command line tool for every API there is. That way we can actually make it work and test it and have fun with it. That shall be done next time though. Thanks for watching and have a great day.